Question 10. We're given an atom of uranium, a nucleus of uranium, and we simply want to determine its charge of a U-239 nucleus. This is just a nucleus, obviously, not the atom, so it's going to have a large positive charge, which will be this number. It wants it in coulombs, so that's simply going to be 92 times the charge on a proton, which is the same as the charge on an electron, but positive, 1.60 times 10 raised to the power minus 19 coulombs. That gives us an answer of 1.47 times 10 to the minus 17. Comparatively big, but still a very tiny charge. Part 2. A positive ion with a 239 uranium nucleus has a charge of 4.8 times 10 to the minus 19. So the charge is, just make a note of that, 4.8 times 10 to the minus 19 coulombs. Determine how many electrons are in this ion. So it's a positive ion, so it must have lost electrons. If it gained electrons, it would be a negative ion. And all we need to do is work out how many electrons are in this. So the charge on an electron is 1.6 times 10 to the minus 19. So it's really just looking at the ratio of this number here, 4.8 times 10 to the minus 19 divided by 1.6 times 10 to the minus 19. We're seeing how many times this goes into that. Of course, the indices can all be cancelled out, so I know that 1.6 goes into 4.8 3 times, so that means there's 3 electrons. It says determine how many electrons are in this ion. Don't forget it says lost electrons, so it has lost 3 electrons. That means that if I want to work this out, I've got to take the original number of electrons, which is the same as the proton number, which will be 92, minus 3, which means we're left with 89 electrons as our answer. Okay. Part B. A 239 uranium nucleus may decay by emitting 2 beta minus particles to form a plutonium nucleus, which is given as X, Y, P, U. State what X and Y represent and give the numerical value of each. Okay, so X, well, that is the atomic number, the one at the top, sorry, the mass number, got it wrong. So that's going to be the same as before, because with beta decay, it's only the bottom number which increases by 1. The atomic mass stays the same. So X is the atomic mass, and no matter how many beta decays it goes through, it's going to remain the same. It's going to be 239. The bottom number, Y, this of course is the proton number or atomic number. This is slightly different because with beta minus decay, basically it's Y plus 1. The bottom number is going to increase by 1 each time. Remember, we've got 2 beta minus decays going on, so that's simply going to be 92 plus 2, which means the bottom number will be 94. And that is 4 marks.